Welcome to your Parent and Student Exam Guide. Let's work through this question together, step by step. Today, we're looking at rectangle and square perimeters. This worked example is from gotestprep.com.au, Australia's leading online preparation platform for New South Wales selective and opportunity class exams.
Okay, so here's what we're looking at. A square is divided into 4 identical rectangles. Each rectangle has a perimeter of 120 centimetres. What is the perimeter of the square? Option A is 160 centimetres, option B is 192 centimetres, option C is 200 centimetres, option D is 180 centimetres, and finally option E is 240 centimetres. Those are all 5 choices. To find the square's perimeter, we'll define side proportions from the 4 identical rectangles, then work from each rectangle's given perimeter of 120 centimetres.
To find the perimeter of the outer square, let's look closely at the relationship between its side lengths and the slices inside. We are given that a large square is cut into 4 identical rectangles stacked horizontally. If we define the short vertical side of one small rectangle as our base unit, x, then the total vertical height of our square is made of 4 of these equal parts, giving us a length of 4x. Since a square must have equal sides, its horizontal width must also measure exactly 4x. This means every small rectangle has a long side of 4x and a short side of 1x. Now let's use our second clue. Each of these identical rectangles has an absolute perimeter of 120 centimetres. The perimeter of any rectangle is calculated by adding 2 lengths and 2 widths together. Substituting our side variables into this rule, our rectangle's perimeter equals 2 times open brackets 4x plus 1x close brackets. 4x plus 1x simplifies to 5x, and doubling that gives us a total perimeter value of 10x. We can now state that 10x is equal to exactly 120 centimetres. With our equation 10x equals 120 established, we solve for our single vertical block unit by dividing 120 by 10. This reveals that x is exactly 12 centimetres. Now we can easily determine the actual physical dimensions of our square. The side length of our outer square is defined as 4x. Multiplying 4 by 12, we find that each edge of the large outer square measures exactly 48 centimetres. Our ultimate goal is to find the total perimeter of the large square. Since a square possesses 4 equal perimeter outer boundaries, we multiply our newly calculated side length of 48 centimetres by 4. 48 multiplied by 4 gives us a final calculation of exactly 192 centimetres. This completes our geometric puzzle. Here's an elite exam strategy to optimize your speed and accuracy on shape partition problems. On highly competitive tests, you can completely bypass calculating the absolute individual length of x by comparing unit boundary weights directly. On your scratch pad, write down the border counts. A single rectangle's boundary consists of 10 unit steps, while the square's outer boundary is made of 16 unit steps. This sets up a direct scaling ratio of 16 over 10, or exactly 1.6. Multiplying the given rectangle perimeter of 120 straight by 1.6 shortcuts you to 192 in a single calculation step. This master strategy eliminates half your scratch work and keeps you moving rapidly. Checking back against our original multiple-choice test sheet options, our derived value of 192 centimetres matches option B perfectly. By establishing clear algebraic proportions, mapping our dimensions, and verifying our steps with our ratio shortcut, we secured the correct result with complete confidence. We select option B as our final answer.
If you found that helpful, visit gotestprep.com.au. We have comprehensive lesson-by-lesson courses for NSW Selective and opportunity class tests with detailed explanations so you can immediately target your weak areas, along with full timed practice tests that simulate the actual exam. You can get started for free. That's gotestprep.com.au. Link in the description.